Welcome back, everybody. Ready to dive into some more fascinating research.
Always.
Today, we're looking at a study that really gets to the core of how a mother's health can impact her baby.
Hmm. Sounds intriguing.
Specifically, how a mother's health during pregnancy can actually change the composition of her breast milk.
Oh, wow. And how does this study approach that?
Well, it focuses on something we don't always talk about: inflammatory markers in breast milk.
Yeah, usually it's all about the nutritional value.
Exactly. This study really goes beyond that.
Looking at the role of inflammation instead.
That's right. And to do this, the researchers focused on a specific group: mothers of very low birth weight infants,
The tiniest babies?
those born under 1,250 grams.
Makes sense to focus on them.
They're so vulnerable. Right.
Exactly.
So the study analyzed their breast milk samples over several weeks after they gave birth.
And what exactly were they looking for in these samples?
Well, they were particularly interested in seeing how things like obesity or pre-eclampsia during pregnancy
Conditions we know are linked to inflammation.
might affect the levels of inflammatory markers and fatty acids in the milk.
Fascinating.
And one of the most interesting findings revolved around C-reactive protein,
Ah, CRP.
a well-established marker of inflammation.
Definitely.
What did they discover about CRP levels in these mothers' breast milk?
Well, one of the key findings was that mothers who were overweight or obese before pregnancy
Okay.
had significantly higher CRP levels in their milk, especially in those first few days postpartum.
Wow, so even before the baby is born, a mother's weight can impact the inflammatory environment of her milk.
Seems that way.
It's fascinating how interconnected everything is.
It really is.
Now, these CRP levels did go down over time for all the mothers,
Regardless of their weight before pregnancy.
but it still raises a question.
Yeah,
Could even a short-term spike in CRP affect a preterm infant?
especially in those early days and weeks.
Exactly, when they're so vulnerable.
Makes you wonder.
Right. Now, before we move on, I do want to address something that might be on some listeners' minds.
Oh, and
Some people might worry that if they had a condition like being overweight before pregnancy, their breast milk isn't as good.
I understand that concern.
It's important to remember that even with these variations, breast milk is still the best,
Absolutely. The best source of nutrition and protection.
especially for preterm infants.
This research isn't about making mothers feel bad
It's about empowering them with information.
so they can make the best choices for themselves and their babies.
Exactly. Now, what I found really interesting is that despite the difference in CRP levels, the study actually found something unexpected about the other inflammatory markers.
Oh, what was that?
Well, they looked at a variety of markers, including cytokines.
Those signaling molecules.
Right, and they found no significant differences in the levels of most of these.
Wait, so even though COT levels varied,
The levels of other inflammatory substances like cytokines were basically the same.
that's surprising. So it's not a simple picture then.
Definitely not. It seems some aspects of a mother's health might have a more direct impact than others.
Which makes this research even more important.
To help us tease apart these complex relationships,
Understand how a mother's body adapts to support her baby.
it's really quite remarkable.
It is.
And I'm sure there's still so much more to discover.
Absolutely. We're just scratching the surface.
Well, I'm definitely ready to scratch a little deeper. So let's talk about something crucial for these babies' development: fatty acids. Did the researchers find any differences in the fatty acid profiles of breast milk based on a mother's health?
Or they did. And this is an area where a mother's pre-pregnancy health does seem to have a bigger impact.
Oh, okay. Tell me more.
For example, mothers with a normal BMI tended to have lower levels of saturated fatty acids.
Interesting.
And you know what else they found? Higher levels of DHA.
DHA.
That beneficial omega-3 fatty acid, the one that's so crucial for brain development, especially in preterm infants.
Yeah, that makes sense. We hear all the time about how crucial DHA is for babies' brains.
Right. Higher levels of DHA in their breast milk. DHA is a crucial omega-3 fatty acid, especially when we're talking about the rapidly developing brains of preterm infants.
That makes sense. We always hear about how important DHA is for babies' brain development. But what about the mothers who weren't within the normal BMI range? Did their breast milk show any differences in terms of fatty acids?
Yes, there were some notable differences. Mothers with overweight or obesity tended to have higher ratios of omega-6 to omega-3 fatty acids in their milk, particularly over time.
That's interesting. So while it's not necessarily a case of their breast milk being deficient in essential fatty acids, the balance might not be as optimal.
Exactly. And it really highlights the intricate ways in which a mother's pre-pregnancy health can impact the composition of her breast milk.
Okay, let's unpack this a bit more. We know that both omega-6 and omega-3 fatty acids are essential, but they play different roles in the body, right?
Absolutely. Both are crucial for various bodily functions. But in simple terms, you can think of omega-6s as promoting inflammation, while omega-3s tend to have anti-inflammatory effects.
So, having a higher ratio of omega-6s to omega-3s could potentially tip the scales towards a more pro-inflammatory environment in a preterm infant's body.
That's a possibility researchers are exploring. Remember, preterm infants have immature immune systems, making them more vulnerable to the effects of inflammation.
Yeah.
So even subtle shifts in the balance of these fatty acids could potentially have an impact.
I see. It's like a delicate dance between these different components, and achieving the right balance is key.
Precisely. And it's an area where targeted interventions might be particularly helpful.
Oh, like what kind of interventions are you thinking about potential dietary changes for the mothers?
Exactly. The study authors suggest that some of these differences in fatty acid profiles could potentially be modified through dietary interventions. For instance, increasing the mother's intake of DHA-rich foods, such as fatty fish or certain algae supplements, might help nudge that omega-6 to omega-3 ratio in a more favorable direction.
So imagine this. A mother who maybe had some pre-pregnancy health challenges is empowered with this knowledge. She makes a few simple tweaks to her diet, and it actually leads to measurable improvements in the composition of her breast milk. It's like personalized nutrition, but for the tiniest humans.
I love how you put that. It's a testament to the incredible adaptability of the human body and the interconnectedness of maternal health and infant well-being.
It really is amazing. And speaking of those connections, this study also looked at other maternal health conditions besides pre-pregnancy weight, right?
Mhm.
Things like pre-eclampsia, gestational diabetes, even the mode of delivery. What did they find in those areas?
That's right. The researchers wanted to see if these conditions, which are often associated with increased inflammation in the mother's body, would also show up in the composition of her breast milk. And what they found is that the picture is complex, just like we saw with the fatty acid profiles.
So, no easy answers.
Not exactly. For some inflammatory markers, like certain cytokines, there weren't significant differences between mothers with these conditions and those without. But for others, like CRP, the differences were more pronounced, at least initially.
It sounds like we need to look at each of these health conditions and their potential impact on breast milk individually, rather than trying to make sweeping generalizations.
I agree. It underscores the need for more research that delves into the specific mechanisms at play. What are the unique pathways by which each of these conditions might influence breast milk composition? And what are the potential implications for the developing infant?
It's like we're piecing together a giant puzzle, and each study adds another crucial piece.
Exactly. And this study is a significant piece, but we need more to see the whole picture.
Well, this deep dive has certainly sparked a lot of curiosity and new questions for me, and I imagine our listeners are feeling the same way. But before we get into the potential long-term implications of these findings, I want to circle back to something we touched upon earlier: the potential link between elevated inflammatory markers in breast milk and the risk of certain health problems in preterm infants. Can you elaborate on that a bit more?
Of course. While breast milk remains the best source of nutrition and protection for preterm infants, there's a growing body of research suggesting that exposure to elevated levels of certain inflammatory markers, such as interleukin-6 in breast milk, could potentially increase the risk of conditions like necrotizing enterocolitis, or AEC for short.
NEC, I've heard of that. It's a serious intestinal condition that can affect preterm infants, right?
Yes, that's right. It's a condition that causes inflammation and damage to the lining of the intestines. And while there are likely multiple factors involved in its development, some studies suggest that exposure to higher levels of certain inflammatory markers in breast milk might play a role.
That sounds concerning.
It is a serious condition, and it highlights the importance of understanding the delicate balance of the infant gut microbiome and the potential impact of maternal health factors on its development.
Right. Because even though a mother's body is doing its best to provide for her baby, there might be subtle variations in breast milk composition that could, unfortunately, have unintended consequences for a vulnerable preterm infant.
Precisely. And this is where further research is crucial. We need to unravel these complex relationships to develop strategies that can optimize breast milk composition and minimize potential risks for these fragile babies.
Okay, so we've covered a lot of ground, from the impact of prepregnancy weight on CRP levels to the delicate balance of fatty acids and the potential link between inflammatory markers and conditions like NEC. It's a lot to take in, and I'm sure our listeners are eager to hear what it all means in the grand scheme of things.
Absolutely. So let's shift our focus now to the bigger picture. What might these findings mean in the long run? Could the composition of breast milk in those early weeks and months have implications that extend far beyond infancy?
That's the question on everyone's mind, isn't it? We'll explore those fascinating long-term implications and delve into the exciting possibilities of future research in the final part of our deep dive. Stay tuned. Welcome back to the show. We've been deep diving into how a mother's health can actually impact her breast milk.
Especially for those tiniest babies born prematurely.
Right, those born very early. We've seen how things like weight before pregnancy and other health conditions can change the levels of certain things in the milk.
Like those inflammatory markers and fatty acids.
Exactly. And we've talked about what that might mean for the baby right away.
In those first few days and weeks.
But now I want to step back and think bigger.
The bigger picture.
What could these findings mean down the road?
You're thinking about the long term.
Exactly. Could these differences in breast milk have effects that last way beyond infancy?
Well, that's where things get really fascinating. We're talking about the possibility of something called developmental programming.
Developmental programming. I've never heard of that. What is it?
It's a pretty complex concept. But essentially, it means that what a baby is exposed to very early in life
Like in those first few weeks and months?
can actually have an impact on their health trajectory as they grow up.
Oh, wow. So you're saying that because a mother's health during pregnancy can change her breast milk,
And because that milk is so vital for a baby's development,
it creates a ripple effect that could impact their health years later.
potentially even decades later.
It's like their early experiences are setting the stage for their future health.
That's a good way to put it.
This is especially important for those preterm babies we've been talking about.
Oh, absolutely. They already face a higher risk of health issues.
So the composition of their mother's milk becomes even more crucial.
Think about it.
Yeah.
What if those differences we talked about, like the inflammatory markers,
Even if those differences are only temporary,
could actually influence how the baby's immune system develops?
making them more likely to have allergies or autoimmune problems later on?
That's one possibility researchers are looking into.
And what about the fatty acids? Could those differences in omega-3s have an impact on things like learning or mental health later in life?
Well, we know DHA is super important for brain development, and some studies are suggesting that early exposure to certain fatty acids could actually shape the brain's structure and function.
Wow, that is fascinating. So much is happening in those first few months of life.
More than we ever realized.
It really shows how powerful breast milk is.
And how important it is to understand how all these factors work together.
It seems like we're just beginning to scratch the surface of all this.
Oh, absolutely. We need much more research, especially long-term studies that follow these babies as they grow.
What would your dream study look like?
If I could design any study, I'd want to follow a large group of preterm infants from birth all the way to adulthood
For years and years.
and meticulously track their health outcomes, looking for any connections back to their mother's breast milk.
That would be incredible.
We could finally see what those early differences really mean in the long run,
And maybe even figure out which components in breast milk are the most beneficial.
or even which ones might be risky.
And with that knowledge, we could come up with ways to optimize breast milk.
To give these babies the best possible chance at a healthy life.
It would be like personalized medicine, but for infants.
Exactly. Using what we know to tailor interventions to each mother and baby.
Well, this has certainly been an eye-opening deep dive.
I agree. It really highlights how interconnected a mother's health and her baby's well-being are.
From pregnancy all the way through adulthood.
And on such a tiny level, too, the microscopic composition of breast milk.
Thank you so much for joining me on this journey, and thank you to all our listeners for tuning in.
We hope you've learned something new about this incredible and often overlooked aspect of early life.
Until next time, keep those brains curious and keep on diving deep.